Intelligent systems are those that sense the environment or other inputs and react accordingly. They use artificial intelligence and machine learning. Essentially, intelligent systems contain computational elements to help them do their job better.
Any system can be made intelligent if they can adapt based on the data, based on prior experience. Intelligent system is more than AI. In AI, we mostly focus on how to analyze data and how to make decisions. But to develop a system, you need other parts, like you need to develop the hardware.
Intelligent systems can include everything from smartwatches to self-driving cars to robots that assemble those self-driving cars.
Intelligent system design is very important because it lays the foundation to support the computations for those emerging applications. It also supports for the next generation of computing.
The ISE program is the first of its kind in the nation and in the world.
At Ladis School, we have faculties working on very different disciplines. So a lot of people, they work together to work on some multidisciplinary research. In this case, I think students here can get a lot of opportunities to working on cutting-edge topics.
Some areas of research include computer engineering, cyber-physical systems engineering, bioengineering, molecular and nanoscale engineering.
We cover different aspects of intelligent systems, from biological sensors to robotics to environmental sensors to data processing, deep learning systems, and so on. We encourage students from any discipline, from any background.
Some of my work involves intelligent networks that bridge the gap between cloud computing resources and user devices, allowing them to work together in a seamless and more efficient system.
I mostly work on how to scale really large-scale graph and network computations, and how to learn from really structured data such as social and biological networks.
I work in this area called machine listening, which is basically developing some machine learning AI algorithm that can understand sound better. My goal is to pushing AI more towards the edge of the computer network, so that people can use them on the small devices that they use every day.
Currently, my research focus is really on how can we design computing systems for big data applications, including machine learning and genomic applications. What I'm trying to do here is we can lower the barrier so that we can just design portable devices so that normal people can use at home. They don't need to send their sensitive data to the data center.
But as we increasingly rely on these embedded systems that are pervasive and around us, we need to understand them, and we need to be able to ensure that they are in fact secure and doing what we want.
The size of networks are growing, and our ability to sense data is also improving. Both the data collection side and the processing side must evolve together. And that is the future, because the data is increasing, the analysis technology must improve as well.
I think for the next generation of computing, we are looking for a computing system which is highly performant, energy efficient, heterogeneous, as well as environmentally sustainable.
The computing continuum, from high-performance computing in the cloud to edge devices to intelligent networks, is the path toward the future.
If you can find out those interesting problems that with which you can feel your heartbeat, then yeah, that's the moment that you can devote yourself to this kind of research.